Welcome back to class. The other day we talked about solving a system of equations using the graphing method. Today we're going to continue in packet number 13 using substitution method. At this point, we've learned how to solve a linear system by graphing. We've also learned that there are three types of solutions to a linear system, just as a reminder. We can have one solution where there's a point. The two lines intersect, and there's our solution. We can have no solution, which is when the two lines are parallel to each other and they never cross. And then finally, we have infinitely many solutions when the two lines are actually right on top of each other because they have the same slope and the same y-intercept. Today, we're going to discuss the substitution method. In this case, we're going to substitute to find one variable, and then we will substitute again to find the second one. So since that double substitution, that's why it's called the substitution method. Here are the steps. It usually doesn't make sense the first time through. It's probably better for you to see examples, but I just want to read you the steps. First, we're going to pick one equation and isolate one of its variables so that the equation reads either x equals or y equals. I believe I have almost all of our equations set up so that there is already one isolated. Step 2, substitute what you found the isolated variable to equal in for the same variable in the other equation. This should leave you only one variable in the new equation you created. Now we're going to solve the new equation for the remaining variable. And then once you know the value of that variable you found in step 3, you're going to substitute it back into the original equations to solve for the other missing variable. Then we always write our answer as an ordered pair because we're looking for that solution. I know that sounds confusing, but let's do one together and maybe that'll help. So in this first example, we have y equals x plus 1 and 2x plus y equals 7. So I want you to draw a line. And I'm going to copy down the equation that already has an isolated variable. In this case, our top equation has the y isolated. So I'm going to put y equals x plus 1 on the first side. And then my other equation, 2x plus y equals 7, is going to go on the right. Notice that y equals x plus 1, the y is balanced out with the x plus 1, or it equals x plus 1. That means any place I see y in the other equation, right here, I'm going to replace it with x plus 1. So I will have 2x plus, and in place of y, I'm going to substitute in this x plus 1 equals 7. I'm now going to solve my new equation. 2x, this is technically a 1x, so 2x plus 1x, combining like terms, I get 3x plus 1 equals 7. We're going to solve equations just like we did back in September. Go back in your little time machine. We're going to say we need to get that variable by itself. First, I'm going to subtract the 1 to get 3x equals 6. And then to get x completely isolated, we're going to divide both sides by 3. When I've completed that, I end up with x equals 2. Now that I know that x equals 2, I can come back to my original equation, y equals x plus 1, and I'm going to substitute in for our x. So I'm going to take this x equals 2 and substitute it in for this x right here. So instead of x, I have 2 and then plus 1. So 2 plus 1 is 3, so y equals 3. You're not going to be completely done until you write your ordered pair. Remembering an ordered pair is an x comma y. So what is our x value? 2. What is our y value? 3, which means these two lines would cross at 2, 3. Okay, still a little confused? Let's look at our next example. Example 2. 2x plus 3y equals -7. I'm going to start with my wall, and I'm going to write down the equation that has a variable isolated. 2x plus 3y equals -7 does not have it isolated, so it's going to go on the right. X equals 4y plus 13 is the one that's isolated, so it goes on the left, but not in highlighter. X equals 4y plus 13. So we're going to take what the x equals, because x is isolated, this is what it equals, and anywhere I see x, I'm going to substitute it into my other equation. So in place of x, I put parentheses, plus 3y equals -7. What am I going to put inside those parentheses? 4y plus 13. Okay, and we're going to start to solve this multi-step equation just like we would do when we did it in September. So we're going to start by distributing to get rid of that 2. 2 times 4y is 8y. 2 times 13 is 26, plus 3y equals -7. Notice we started with 2 variables in the original equation, and now we have the same variable instead. They're both y's instead of an x and a y. So we're going to combine like terms, the 8y and the 3y. They're on the same side of that equal sign, so we add them. 8 plus 3y is 11y, plus 26 equals -7. We want to get 11y by itself, so I'm subtracting 26 from both sides to get 11y equals -33. To get the y completely by itself, we're dividing both sides by 11 to end up with y equals -3. We're not finished yet, though, because we're going to take that y equals 3 and substitute it back in for our y. So we're going to have x equals 4. I'm going to put parentheses instead of y, plus 13. And we're going to take that -3 and put it in place of for y. And then solve. 4 times -3 is -12. -12 plus a +13 is going to be a +1. Remember that your final answer isn't just having an x and a y. You have to have your ordered pair, which is x comma y. Our x is +1. Our y is -3. So our final answer is 1, -3. Let's look at another example. Y equals 2x plus 3, and 4x plus 2y equals 6. I'm going to draw my wall. I'm going to put the one that has our variable isolated on the left side. So should I put y equals -2x plus 3, the top equation, on the left? Or should I put 4x plus 2y equals 6 on the left? We're going to put y equals -2x plus 3 on the left because the y is already isolated. And we're going to put 4x plus 2y equals 6 on the right. I'm going to substitute in -2x plus 3 anywhere I see y in the other equation. So 4x plus 2, put the parentheses, equals 6. This variable over here, whichever one is isolated, is what determines where the parentheses go. In those parentheses, I'm putting -2x plus 3, and we're going to start the process of solving. In this case, we get rid of those parentheses by distributing. So I'm going to have 4x minus 4x, because 2 times -2 is -4. 2 times 3 is 6, equals 6. We're going to combine like terms. We have a 4x and a -4x. They combine and cancel each other out. So when they cancel each other out, we're left with 6 equals 6. Does 6 equal 6? If yes, then it's going to be infinitely many. If it was not true, we would put no solution. But since they equal each other, our answer is going to be infinitely many, meaning any point we put in for x and y in either equation will make it true. And our last example is going to be 3x plus y equals 5, and -6x minus 2y equals -8. Here, neither of the equations have a variable isolated. But which equation, equation 1 or equation 2, has a variable with a coefficient of 1, meaning the number in front of it is 1. So if I look at the top one, 3x plus y equals 5, and the bottom one is -6x minus 2y equals -8. The top one, 3x plus y equals 5, has a y with a coefficient of 1. So I just need to get that y by itself. To do that, think about putting it into slope-intercept form in this case. We're going to subtract 3x from both sides to get y equals -3x plus 5. The other equation, negative 6x minus 2y equals negative 8, is going to go on the right. We have y isolated, which means when I go to rewrite the other equation, the parentheses go in place of the y. This way, we'll only be working with x's. Negative 3x plus 5 is going to go inside those parentheses. And we're going to start to solve it just like we did back in the fall. We're going to distribute. Negative 2 times negative 3x is a positive 6x. Negative 2 times 5 is a negative 10. And that equals negative 8. We're going to combine like terms. Negative 6x and positive 6x actually cancel each other out, leaving us with negative 10 equals negative 8. Does negative 10 equal negative 8? Is that true or false? It's a false statement. So since it's a false statement, it's going to be a no solution answer. Take your time to complete this, and then you're going to answer questions on the Nearpod, and from there, you'll be assigned the homework.